Can you use the result to find the solution of the problem by our own means is a discovery. If the problem is not difficult, the discovery is not so momentous, but it is a discovery nevertheless. Having made some discovery, however modest, we should not fail to inquire whether there is something more behind it. We should not miss the possibilities opened up by the new result. We should try to use again the procedure used. Exploit your success. Can you use the result or the method for some other problem? 1. We can easily imagine new problems if we are somewhat familiar with the principal means of the Bellingen problem as a generalization, specialization, analogy, decomposing, and recombining. We start from the proposed problem we derived from it others by the means we just mentioned. From the problem we obtained, we derive still others, and so on. The process is unlimited in the theory, but in practice, we seldom carry it very far because the problems that we obtain are opted to be inaccessible. On the other hand, we can construct new problems which we can easily solve using a solution of the problem previously solved. Yes. But these easy new problems are apt to be uninteresting. To find a new problem which is both interesting and accessible is not so easy. We need experiences, taste, and good luck. Yet we should not fail to look around for more good problems when we have succeeded in solving one. Good problems and mushrooms of the certain kinds have something in common. They grow in clusters. Having found one, you should look around. There is a good chance that there are some more quite near. 2. We are going to illustrate some of the foregoing points by the same example that we discussed in section 8, 10, 12, 14, 15. Thus, we start from the following problem. Given the three dimensions, length, breadth, and height of the rectangular parallel pipe, find the diagonal. If we know the solution of this problem, we can easily solve any of the following problems, of which the first two were almost stated in section 14. Given the three dimensions of the rectangular parallel pipe, find the radius of the circumscribed sphere. The basis of the pyramid is a rectangle of which the center is foot of the altitude of the pyramid. Given the altitude of the pyramid and side of its base, find the lateral edges. Given the rectangular coordinate xy, x1, y1, z1, x2, I'm sorry, bracket x1, y1, z1, bracket x2, y2, z2, of 2 points in the space, find the distance of these points. Yes, I've just learned it. We solve these problems easily because they are scarily different from the original problem whose solution we know. In each case, we add some new notion to our original problem as circumscribed sphere, pyramid, rectangular coordinates. These notions are easily added and easily eliminated, and having got rid of them, we fall back upon our original problem. The foregoing problems have a certain interest because the notion that we introduced into the original problem are interesting. Wow. The last problem that about the distance of the 2 points given by their coordinate is even important problem because rectangular coordinates are important. So this is logical circuit. It's being logic for endless. That's fun, which is fun. 3. Here is another problem which we can easily solve if we know the solution of our original problem. Given the length, the breadth, and the diagonal of the rectangular parallel pipe, find the height. In fact, the solution of our original problem consists essentially in establishing a relation among four quantities. the three dimensions of the parallel pipe and its diagonal. If any three of these four quantities are given, we can calculate the force from the relations. Thus, we can solve the new problem. We have here a pattern to derive easily solvable new problems from the problem we have solved. We regard the original unknown as a given and one of the original data as unknown. The relation connecting the unknown and the data is the same in both problems, the old and the new. Having found this relation in one, we can use it also in other. Wow! So cool, so cool. This pattern of deriving new problems by interchanging the roles is very different from the patterns followed under the two. 4. Let us now derive some new problems by other means. Wow. A natural generalization of our original problem is the following. Find the diagonal of the parallel pipe being given in the three edges issued from an end point of the diagonal and the three angles between these three edges. By specialization, we obtain the following problem. Find the diagonal of the cube with a given edge. We may be led to an inexhaustible variety of the problems by analogy. Here are a few derived from those considered under the two. Find the diagonal of the rectangular. Find the diagonal of the regular octahedron with a given edge. Find the result. Find the radius of the circumscribed sphere of the regular tetrahedron with a given edge. Given the geographical coordinates, latitude and longitude of the 2 points on the Earth's surface, which we regard as a sphere, find their spherical distance. All these problems are interesting, but only the one obtained by specialization can be solved immediately on the basis of the solution of the original problem. Wow. So good. 5. We may derive new problems from the proposed one by considering certain of its elements are variable. A special case of the problem mentioned under 2 is to find the radius of the sphere circumscribed about the cube whose edges is given. Wow. Let us regard the cube and the common center of the cube and sphere as fixed. But let us vary the radius of the sphere. If this radius is small, the sphere is contained in the cube. As the radius increases, the sphere expands, as a rubber balloon in the process of being inflated. At certain moments, the sphere touches the faces of the cube. A little later, its edges. Still later, the sphere passes through the vertices. Which values does the radius assume at these three critical moments? Holy moly. 6. The mathematical experiences of the student is incomplete if he never had an opportunity to solve a problem invented by himself. The teacher may show the derivation of the new problems from one just solved, and doing so provoke the curiosity of students. The teacher may also have some parts of the invention to students. For instance, he may tell about the expanding sphere we just discussed, and ask, what would you try to calculate? Which value of the radius is particularly interesting? Wow, thank you.
Until in anger they shake the rein and start the rollicking hunt again, galloping.